Assalamualaikum and Selamat Hari Raya to everyone. As for today, one of the group from FL3, which is us, gonna present about topic 5 in the course FAD 1008. As first and foremost, we know that from the question given, compound A and compound B is a hydrocarbon and they are anisomers. First and foremost, they're gonna undergo a reaction which is ozonolysis that's gonna produce a single organic product which is compound C. And compound C gonna undergo a reaction which is an oxidation reaction that gonna produce compound D which is a carboxylic acid.
Okay, for experiment 2, it is found that compound A is polar while compound B is non-polar. And when the compound A react with cold neutral potassium permanganate, it give a meso compound E. And when compound B react with cold neutral potassium permanganate, it give a racemic mixture F and G. And it is found also when the compound B have a electrophilic addition reaction, which is halogenation. When compound B react with bromine in CCl4, it gives a non-polar compound H.
Okay, next, given structure A and B contain 85.7% weight per weight carbon. So the left is 14.3% weight per weight is for hydrogen. Find the ratio, which is 1, 2, and empirical formula CH2, and the formula is CnH2n, which is the alkene group. Next, we find the molecular mass from ideal gas equation. We include the division of 2 here because the structure A and B will undergo ozonolysis and the R group will spread into 2. And then we get the molecular mass is 102 gram per mole. Next, we try to make a gas by doing the R, which is the third butyl, and from the compound D given as our indicator, find the molecular mass and we get 102 gram per mole. And then if we take R as methyl group, it doesn't get as the same down here. First, for compound D, our first indicator, which is carboxylic acid, named 2-dimethyl propanoic acid. Here, as it has carbonyl group, and then attached with the R, which is third butyl. And then the compound D produced from compound C from the process oxidation. So in order to get compound C, we need to reverse the reaction, which is reduction process. Next, compound C, 2,2-dimethyl propanol, which is aldehyde functional group. The compound D undergo reduction process, which is the oxygen atom from hydroxyl group will break, and then we have the compound C. And also compound C is produced from ozonolysis reaction.
Okay, next one. We need to check whether C10H20 is the right compound or not. So we plug into the concentration weight per weight formula, which is mass of carbon divided by mass of compound and multiplied by 100. And here we get 85.7%, as this is the same percentage as the question given. Next one. This diagram shows the polarity of 2 isomers. Okay, for the first one is the cis isomer, which is the dipole is in the same direction, Hence, the net dipole is not equal to 0, whilst the trans isomer at the right side, the dipole is in opposite direction and the net dipole is equal to 0. This proves that the first compound, which is the cis isomer, is polar, and the second isomer, the trans isomer, is non-polar. Here is compound A, as the structure shown at the left side. It is cis 2255 tetramethyl hextriene because there are two methyl groups attached to carbon number 2, while the other two methyl groups are attached to carbon number 5, and the double bond is at carbon number 3. Same goes to compound B, but this is isomer, so the compound B is trans. It is because each atom is at the opposite side.
Okay, so for compound A and compound B is isomer. Compound A is cis, meanwhile B is trans. Both of this compound is geometrical isomer. So for compound A, we got cis 225 tetramethyl hextriene. Meanwhile, compound B, we got trans 225 tetramethyl hextriene. Okay, both of that compound go through ozonolysis, and then we got compound C, which is two compound C named 2,2-dimethyl-propanol, and then this compound go through oxidation, and we got 2,2-dimethyl-propanoic acid.
Since we already got the name and the structure of compound A and compound E, upon reaction of compound A with cold potassium permanganate, we will get a compound E, which is a mixed compound, and compound A undergoes dihydroxylation. Compound E is a mixed compound because it has a plane of symmetry, and the double bond in the compound A will break and bond to two hydroxyl group, and the name of compound E is 2255 tetramethylhexane 3,4-diol. When compound B react with cold potassium permanganate, which is a dihydroxylation, we will get a racemic mixture of compound F and G. And the name of the mixture is 2,2-dimethyl 3,4-hexane diol, and both compound F and G is an enantiomer. And when compound B is reacted with bromine in carbon tetrachloride, it gives a compound H which is 2,2-dimethyl 3,4-dibromohexane. Compound B undergoes electrophilic addition to give compound H, and compound H is a non-polar. Compound H has more stable conformation because the two Br in the structure is pointing away from each other, and when the position of each bromine is opposite to each other, the dipole moment is nonpolar. And if we rotate the position of carbon of one carbon, it becomes meso compound because it has an axis of symmetry.